In this video, we look at custom response objects and headers in FastAPI. By default, FastAPI handles the response for you, but sometimes you need to take the wheel, setting your own headers, cookies, or status codes at runtime. That is exactly what we will learn here. FastAPI's default behavior is great. You return a Python dict or a Pydantic model, and FastAPI wraps it in a JSON response automatically. But real APIs often need more: a cache control header, a set cookie header, or a status code that depends on what happened inside the function, not a fixed value declared on the decorator. With plain return values alone, there is no obvious place to attach any of that. Think of an HTTP response as an envelope. Most of the time, you only care about the letter inside, the JSON body. But an envelope also carries metadata on the outside: where it came from, how it should be handled, whether it is express mail. HTTP headers and cookies are exactly that outer metadata. FastAPI's custom response tools let you write on the envelope, not just stuff the letter inside. FastAPI gives you 4 key pieces. First, the base response class, which you can return directly when you need total control over the body, status, and headers. Second, JSONResponse, a convenient subclass that takes a Python dict and serializes it. Third, a special injected response parameter. When you declare a parameter typed as response in your function signature, FastAPI injects a mutable response object so you can add headers and cookies while still returning a normal value for automatic docs. Fourth, the .headers dict and the setCookie method on any response object. Let us walk through this file top to bottom. We import FastAPI, response and status from FastAPI, then JSONResponse from FastAPI.responses, and base model from Pydantic. In pattern 1, the route function declares a parameter called response typed as response. FastAPI sees that type hint and injects a live response object before the function runs. We then write a custom header by treating response.headers like a dict, and we call set_cookie to attach a cookie. We still return a plain dict, so FastAPI generates docs and validates output normally. In pattern 2, we return a JSONResponse directly. If a conflict is detected at runtime, we construct a JSONResponse with a 409 status code, a JSON body, and a custom header, all in one call. Something you simply cannot do with a bare return value. Here is the flow. FastAPI resolves all dependencies first, including injecting the response object if you declared it. Your function runs and mutates that shared object by adding headers or cookies. FastAPI then takes your return value, serializes it, and merges in the headers and cookies you set, so you get the best of both worlds. When you return a JSONResponse directly, FastAPI skips its own serialization and sends your object as is, which means response_model validation does not run, and the OpenAPI schema will not reflect the response body shape. That is the trade-off. More control costs you automatic documentation and output validation. Use the injected response parameter whenever you need to tack on headers or cookies, but still want FastAPI to handle serialization and OpenAPI docs. It is the least disruptive option. Reach for JSONResponse directly only when you genuinely need a different status code at runtime or a completely different body shape. Avoid both when a fixed status code on the decorator or an HTTPException already does the job. Those simpler tools keep your docs accurate and your output validation intact. To recap, injecting response is the low-cost path. You get header and cookie control without giving up serialization or docs. Returning JSONResponse directly is the high-control path, useful for runtime status codes, but you trade away output validation and schema generation. Always ask yourself whether a simpler tool like HTTPException already covers your need before reaching for a custom response object.